For PNC, you need to know about certain methods first of all. I'll um, just tell you what those methods are. You need to know about the gap method, right? So for gap method, you usually have cases where suppose the question is asking you about vowels and consonants, right? And just telling you that the vowels and consonants cannot be together. So in that case, you need to make use of gaps. You would arrange all of your vowels together first of all, something like this, for example. So let's say all these four vowels are unique, right? So that would be 4 factorial, and then you're left with your consonants. So let's say you have three consonants, and all those three consonants are unique. So over here you have 1, 2, 3, 4, 5 gaps, right? So you have 5C3 ways of choosing those gaps, and then because you can rearrange those consonants as well, that would be 3 factorial. So that's a gap method which you need to know about. Um, Wait, so all I said is that for gap method, you need to um, sort of recognize two major groups. So in this case, we are talking about vowels and consonants, right? So in this, you have four vowels and then you have three consonants for this example, right? Um, you can do 5P3 as well. That's completely fine. I prefer to choose and then um, use factorial, but if you do 5C3 times 3 factorial, that would be the same as 5P3, just to clear it up. So yeah, that's for gap method. Um, okay, I'll just go through the next method as well so that it'll be easier for you guys to um, recognize which methods to use as well. So apart from this, you have another method which is known as the block method. Till now we have just covered the gap method. We aren't doing any questions right now. I'll just go through some concepts that you can use for PNC. Okay. Apart from that, you have so you have gap method, right? And then you have wait, hold on, the box method. It doesn't really have any official name, but I'll go through this as well, right? So in questions where they tell you that certain letters have to be together, so let's say yeah, you can just name it whatever you like. Anyway, let's say you have three E's, okay, and a bunch of random unique letters. So let's say you have five unique letters, okay. I'm not gonna waste time writing those. So let's say that the question asks you to find all the cases when the three E's are together, right? So in that case, you would make a box around those three E's, and in this case, those three E's are identical. So you don't have to do factorial or anything. Even if you did, you just do 3 factorial over 3 factorial, right? So it's just 1. Anyway, in box method, you would box the three E's, and then you have, for example, 5 other unique characters, right? And they ask you to find all the possible arrangements. So you have 5 over here, so it would just be 6 factorial. It's pretty simple. You're you can think of this as s- uh, like one item or one giant letter. Although that's not recommended, but think of this as big E or something, right? The arrangement inside that does not matter. So yeah, so far it's pretty easy. Um, so CIE will majorly test you on these two methods. Then you have types of questions where they ask you to find selections. So I included a few of them. Wait, let me just show you. I'll solve these as well. So you have selection type questions where they ask you to sort of fix a couple of letters and then find all these selections where you have some sort of a criteria, right? And then you have probability and combinations together. So these ones are interesting as well. So we'll go through all of this in the session. So okay, let's start with the first one. So in this question, they're telling you that you have 8 children of different ages, right? So usually I just tend to write down because that helps me. So you have Y1, Y2, y3, and so on till y8. You have 8 unique children of different ages basically. So in this case, they're telling you to find the number of different ways this can be done if none of the three youngest children stand next to each other. So they're telling you that um, basically you kind of get the idea that there has to be a gap between those children, right? So that's when you realize that, oh, you have to use the gap method. So usually for the gap method, you start by ignoring these three, like in this case, these three children, and you would arrange the other five children first. So y, gap y, gap y, gap y, gap y, 1, 2, 3, 4, 5, and then you would make gaps over here. Now realize the fact that these three youngest children can only be in these given gaps. They cannot be in any other place. And these five children which I've written, they are unique, right? So first of all, you start by arranging these five children, which is simply 5 factorial. Now after that, you have how many? You have 6 gaps, right? So in 6 gaps, you have to basically arrange three unique people. So you can think of it as 63 times 3 factorial, or it's basically 6p3. And let me just calculate the answer. And that gives you the answer as 14400. 14400. Okay, moving on. In this question, I kind of realized that I'm, yes, this is only happening today. I realized that I actually missed a part of the question. Um, so if you guys have the original PDF for this, do not refer to that because this part wasn't there originally in the original PDF. Anyway, so you're told that you have 12 trees. They're groups of um, yes. This will be recorded, and we'll be uploading the recording so you can refer to that. Anyway, so in this question, you're told that you have 4 different uh, hibiscus trees. Then you have 9 different these type of trees, and then 2 different of this type, right? So you have 3 groups, and keep in mind that all of them are different. So first of all, how many different arrangements of these 12 trees can be made if the hibiscus trees have to be next to each other, the second type have to be next to each other, and the third type have to be next to each other. So you get the idea that they have to be next to each other. So what does that tell you? You have to use the box method once again. Now you can just make use of factorial and you can start calculating, but I personally prefer using some rough diagrams, so I will be doing that. So you have 4H, I just like labeling it like this, 6J, 2 O's, right? So if you were to think about it, you would have 4H in one box, then you would have 6J in one box, and 2 O's in one box. So first of all, think about how you would arrange those letters inside the box before thinking about how you would arrange those boxes itself. So in the first box, it would simply be 4 factorial. Keep in mind that they are different trees. You can think of them as um, the same type of tree, like hibiscus tree, for example, but they have different heights. That's why you treat them as different. Then that times 6 factorial times 2 factorial. And now, once you're done arranging the letters or the trees inside those boxes, you have to think about the ways you can arrange those boxes itself, right? You could have, for example, the O type first, then you could have J, then H, something like that. So the order of those boxes matter as well, so you'd multiply that by 3 factorial. Um, Also, I'll be sharing the drive for this. The drive has the mark scheme, the question paper, everything. So you can refer to that. Okay, so 4 factorial times 6 factorial times 2 So that gives you 27207,360. So 207360. So far so good, right? Wait, hold on, let me see. It's going fine. Okay, moving on. So after this, they're asking you how many different arrangements of these 12 trees can be made if no hibiscus tree is next to uh, another hibiscus tree, right? So again, for this, you can start by again, this kind of tells you that you have to make use of the gap method, right? Because they're telling you that they cannot be next to each other. So what's the main idea in this? The hibiscus trees are not next to each other. So again, you make use of the gap method. So this one is the hibiscus tree. You have the O and J types. So all the hibiscus trees would be between O and J, right? So you would have gaps between the O and J tree types, and that's where the hibiscus trees can be. So start by just making a diagram. So 6 J's, 4, 5, 6, and then you have 2 O's, right? Again, this isn't any specific order because you will be arranging these as well. So start by doing that. You have 1, 2, 3, 4, 5, 6, 7, 8. You have 8 trees basically, keeping in mind the fact that they're different trees, right? They're unique. So there are actually 8 factorial ways to arrange them first of all. Okay. Now, how many gaps do you have? You're basically going to choose certain gaps from the total number of gaps, and you'll be placing your hibiscus trees over there, and then you have to arrange them as well. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 gaps. So you can do 9C4 times 4 factorial, or you can do 9P4. Can both methods be used on the same question, or are the methods supposed to be used on specific use cases? Wait, are you talking about using gap method and the box method together? Because you can use the box method in this as well, to be honest, but that's like an alternative method. If you want, I can talk about that. So anyway, this would be 8 factorial times 9p4. So um, not a lot of people prefer using the alternative method, but what you can do is, since they're telling you, that you have to find all the cases when the hibiscus trees are not together, right? So consider all the cases when some or like some of the hibiscus trees are, wait, actually in this case that would not work. I think there is some question ahead where I can use that. But in this case, no, you'll have to use gap method actually. Um, that would be the only way for this. There are some questions where you can use gap and box method. If I find a question, I'll let you know. How do I figure out which method is the optimal one? It really depends on how your question is framed, if I'm being honest. Like in this case, you can clearly see that they're telling you that none of the trees or none of the hibiscus trees are next to each other, right? So that tells you you have to make use of gaps. And then over here, they're telling you that these hibiscus trees have to be next to each other. So I guess generally you can think of it as when you're given a question where some of the items have to be next to each other, you would start by making a box. And then in questions where they tell you that they aren't supposed to be next to each other, you can make use of the gap method. Honestly, it comes mainly with practice, so you can try solving more of these types, I suppose. Anyway, moving on. So, in the next question, you're told that three identical cans of cola, two identical cans of green tea, and then you have two identical cans of orange juice are arranged in a row. So you have 3C, you have 2G, and then 2O's. And you have to calculate the number of arrangements if the first and last cans in the row are the same type of drink. Okay, So for this, just think about it, right? Um, Start by making dashes. So you have 2, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So you can either have the green type, right? Or you could have the orange type, or you could have the cola type. So I'll just make rough diagrams just so that it makes more sense. 2, 3, 4, 5, 6, 7. So C's and C's. Okay. Now you are basically fixing those type of drinks at those places. So now you're done with this. You don't have to worry about what to do here. Now you just have to think about the remaining 5 cans basically. You have to arrange the 5 cans that are in between, right? So just in each specific case, you would have to look at what you're left with. Then you would have to calculate the arrangements, and then you would add them up at the end. Am I audible? Is everybody facing issues with this? Um, how about now? Is this any better? Yeah, you can right click on my profile and then um, increase it. Okay. Uh, um, that's a bummer. Anyway, I'll try talking more loudly, I guess. Anyway, okay. Right. So in the first case, when you use two of the green types, right? Um, is everybody facing this issue? Okay, I think you should maybe try rejoining or just get a speaker or something. Anyway, moving on. In the first case, you use two of the green types. So you have 3C and then 2O, right? So in all of the cases, you obviously you're left with 5 items to arrange. So for this, for all the cases, you do 5 factorial. But then for the first case, for example, you're left with 3 C's and 2 O's. So you have to account for repetition, right? So in this one, you do 3 factorial, 2 factorial. Then moving on to this, you do the same thing again because you're left with 3 colas and 2 greens for the second case. So that's 5 factorial over 2 factorial, 3 factorial. Then in the third case, you use 2 out of 3 colas, right? So you're left with 1 cola, 2 greens, and 2 oranges. So that would be 5 factorial over 2 factorial, 2 factorial. Now these are three separate cases, right? And all of these three cases are acceptable. So you would add them up to find the final answer. So let me just do that. 5 factorial that upon 3 factorial times 2. Um, and the entire thing by 2 because if you'll notice, these two are basically the same. So just to save time, you can multiply them by 2. That plus 5 factorial over 2 times 2 basically. So that ends up giving you 15 as your answer. And they're asking you for the number of arrangements, right? So your answer would be 50. Um, I'll be sharing the PDF in the statistics channel as well later on. Actually, you know what? Let me just share it again. Okay, I think someone already shared it, but anyway, let me just send it. This is not for March 2026. We're just going, we're just revising some concepts. Okay, moving on. I don't have any space at all. Um, okay, you know what, I'll just erase the left side and then we can do the remaining work over here, right? Okay, hi Pranav. Moving on. So you're told that the three cans of cola are all next to each other, and two cans of green tea are not next to each other, right? So okay, so first of all, you get that you have to box the three cans of cola. That they're always going to be next to each other, and you know that they're identical, right? So you don't have to arrange them inside the box. Just make a box for the three colas, first of all. Now, then you're told that the two cans of green tea are not next to each other. So that that gives you an idea that you have to use the gap method once again. So where can the green teas or the cans of green tea basically be? It could be over here in this gap, in this gap. You're left with two O's, right? So you can uh, arrange them like this, and basically your two green tea types would basically go in these remaining gaps. So for that, you would start by arranging the ones that are not going in the gaps. So the box and the two O's. So that's 3 factorial, right? But keep in mind that the two O's are repeating as well. So you have to account for repetition. So 3 factorial over 2 factorial. And then you have one, two, three, four. You have four gaps, and you have to wait, hold on. You have to put two cans basically. So but again, keep in mind that those two cans are identical. So you could do basically you just do 4C2, or you can do 4P2 upon 2 factorial. That would be the same thing. And if you just calculate the final answer, that would give you 18. Okay. So far, so good. If you guys have any doubts as well, just let me know. I think so far it's not that hard. Okay, moving on to this. This is a really good question as well. I think I got it from one of the mods. Anyway, so a security code consists of two letters followed by four-digit number. So you can have two letters in the first two blanks, and then just make some space, and then four. Wait, can you subtract? Wait, can you subtract three can together with three can together and two can together? Wait, sorry. Can you just frame your question? Um, are you talking about the case where you consider when the two cans of green tea are together, and then you subtract that from the total cases, because you can completely do that. We divide by the factorial thingy because it has no. We divide it by 2 factorial, or you can think of this as 4C2, because look, these two oranges, right? These two oranges are identical. They aren't like O1 and O2. So if they were different, you would usually do 4C2 times 2 factorial, right? But because they are repeating, you divide it by 2 factorial. So the 2 factorial basically cancels out. Three colas together and two green tea together. Yes, you can consider all the total cases and subtract that from uh, the cases where the three colas are together and the two green teas are together. Um, a lot of tea. Okay, moving on. So now moving on. So you're told that the letters are chosen from this and the digits are chosen from your given a set. Now, no letter or digit may appear more than once. And then you're given an example as well. So how many different codes can be formed? So first of all, you'd start by arranging your letters, right? You have five letters in total. So you'd simply do 5p2, or you can think of it as 5c2 times 2 factorial. So 5p2, that times, and then you have 7. Basically, you have 7 numbers, and you have to choose and arrange 4 letters. So that would be 7, P4. Yeah, I think I took this question from you. Okay. So 5P2 times 7P4 would give you 7P4 16800. Now, moving on, find the number of different codes that include the letter A or the digit 5 or both, right? So, again, for this, I'm pretty sure you can use multiple methods for this over here. But what I would do personally is just make your dashes first of all. So, there's an or, right? So you have to consider the case where there's only letter A and you don't have digit 5, and then the case where you have digit 5 but then you don't have A, or the cases where you have both. Now, in the cases, in the first two cases, you don't have to consider, like for letter A, you won't consider digit 5. For digit 5, you won't consider letter A because that would be overcounting, right? So, okay. First of all, you can start by fixing A over here, then make another case where you select 5, and a third case where you have both, right? So 5 and 8. So in this case, you're left with how many? You're left with four. You're basically left with four letters. So first of all, you do 4C1. Now keep in mind that they didn't tell you that A has to be um, at the start or anything. So you would have to arrange A and the letter that you choose as well. So that would be into 2 factorial, or basically 2 times. Now in this case you're ignoring 5. So you have 1, 2, 3, 4, 5, 6. So into 6p4. So let's just calculate the cases as well simultaneously. So 4 times 2 times 6 is 4. That gives you 2880. Okay. Now for the second case, you just use the same logic again. So you won't consider A for this. Wait, let me just erase the file. For the first case, um, wait, why are you doing 6p3? You have four blanks basically, right? In your first case, 5 isn't fixed. You're this case in this case you're basically excluding 5. You're only considering the cases where you have only A and some other characters but not 5. So A but not 5. That's why you have a remaining of 6 numbers. Yeah, you can use multiple cases for this basically. Anyway, for the second case, you won't have an A, right? So you're left with 4, and then that would be 4p2 simply. That times, okay, so now you have to be careful. They didn't specify that 5 has to be at the end, right? So start by selecting all the possible numbers that you can have, and then arrange them at the end. For the, so for this, you won't just do you won't just use the permutation formula right away. Start by choosing. So you have 6 again. So 6c3, right? You already chose the, not the last, but you chose one of the letter numbers already, and that into 4 factorial, because you're going to arrange them as well after choosing. So 4p2 times 6c3 times 4 factorial. Yes, we are aware. Thank you. So 5760. This is your second case. Um, yeah, I'm going really slow. But anyway, um, in the second case, again. You have 4, so 4 into 2, right? You're going to choose 4C1, so 4C1, and you're going to arrange between the two letters, so that's into 2 factorial. Now, you use the same concept as before of choosing from 6, so 6C3, that times 4 factorial. That will give you your third case. 4C1 into 2 into 6C3 into 4 factorial. That gives you 3840. Now you just simply add up these all these cases to get your final answer. It's 5760 plus 3840. So after adding all of that up, you end up with 12480. This would be your final answer. Okay, what else? Now in part C, you have to find the probability that the code D is followed by a number between 4500 and 5000. Um, Again, I do not have space. I'll erase this part. Let me just do this. 12480. Let me divide the space for the third part. Okay. So first of all, DE is fixed, right? You're already fixing DE over here. So DE would just be this. Now you have to think about the remaining four numbers. So again, it has to be between 4500 and 5000. But then keep in mind that since they're telling you between, 5000 is not included. That won't be a case. So for the first for the first blank, the only number you can have is 4. Like that's the only one. You can't have 5 because again they're telling you between. Now after that you have to look at, since they're telling you between 4500 and 5000, this has to be 5 or greater. So what are all the numbers or digits that are 5 or greater? You have 567. 567. Now when you use this sort of a method to find out the probability, just make sure that you're accounting for the fact that no letter or digit may appear more than once, because that's really important. So okay, now the last two blanks can technically have um, any number, right? But again, over here you would select one, right? Over here you can think of it as having three digits that you can select from, and once you select those two digits, you'll basically be left with 5 digits, right? Because again, repetition isn't allowed, and then you'll be left with 4. So those are your favorable outcomes. 1 into 3 into 5 into 4, 60. And what are your total number of outcomes? So again, your total outcomes are just the number of different codes that can be formed, right? So you just do 60 upon 16800. 16800. And this is favorable. Total would be 16800. So probability would be 60 upon 16800, which is 1 over 120. 1 over 280. 1 over 280. Okay. Moving on. Now, this is sort of a different type of a question. Um, so, a group of 8 friends travel to an airport in 2 taxis, P and Q. Um, each taxi can take 4 passengers. Now, each taxi can take 1 passenger in the front and 3 passengers in the back, which is in the diagram. Now Mark sits in the front of taxi P. So no matter what, Mark is going to be. I have no clue. Hopefully this will end in pretty soon. I don't really know the timing though. So the recording will be available anyway. You can just check that out. So Mark would be right. Mark will be fixed over here no matter what because they tell you that Mark sits there, right? And then John and Sarah sit in the back of taxi P. So next to each other. So that's important. Again, they're telling you next to each other, right? So you have to think about making a box. So John and Sarah, they're sort of like in a box. They're stuck together. Now find the number of different seating arrangements that are now possible for the 8 friends. So for taxi queue, there isn't any sort of a restriction, right? So first of all, you just deal with taxi P. We look at that first. So let's say that John and Sarah are sitting like this. First of all, inside the box, start by calculating what happens inside the box. So you have two factorial ways of arranging inside the box, right? Hi. After that, after you select all those three people, Marx, John, and Sarah, you'd be left with 5 friends to choose from for the fourth place. So that would be into 5C1, right? You're basically choosing one friend from the remaining 5 people. Now, another thing is that let's say this is your fourth person, right? Now, your fourth person can kind of swap with the box in a way, or there's basically two factorial ways to arrange them as well. So that would be into 2 factorial. Now you're done with taxi P. Now the remaining people are 4 and you have to arrange them in 4 places. So 4P4 or 4 factorial. Wait, I should have done it over here. Man. Okay, I'll just write it. 2 factorial into 5C1 into 2 factorial into 4 factorial. So if you just calculate that, 2 into 5 into 2 to 4 factorial. That gives you your answer as 480. In the, what's the 4 fact? Oh, thank you. Anyway, what's the 4 factorial for? That's because once you're done with your taxi P, right? You basically arranged 4 people, out of which 3 were John, Sarah, and Mark, and you chose a four. The fourth person was random. Now you're left with 4 people for taxi queue, right? And they can be arranged in basically 4 factorial ways. If you were to think of it as 4 seats, so you have 4 factorial ways to arrange the remaining 4 people. Anyway, the final answer would give come out to be 480. Oh, alright. Okay. So moving on. This is a good question as well. So, um, you have 10 different books from the series Squares and Circles. The books look similar, so that is important. They look similar except for their color. Now, however, at the same time, they're telling you that they are technically 10 different books, right? So the only thing is that their colors might be similar. So you have 3 blue books, you have 2 red books, 2 yellow books, and all of that, right? Let me just erase that. Okay, so just keep in mind that these are technically 10 different books, but if you were to talk about it in context of the colors, um, some of the books have similar colors. So in that sense, they would be identical. Now, for part A, they're asking you how many different color arrangements are there of the 10 books. So when they're basically asking you about the color arrangements, that means it's in context of the colors. So the colors matter in this case. So you have 10 factorial ways to arrange those books, right? But then in terms of colors, they would be identical. So you would simply do divide by 3 factorial for the 3 blue books. Then you have 2 and then 2. The others are just ones there. Alright, good luck. So then you have upon 2 factorial, 2 factorial. So that's 1 mark. 2 into 2 into 6. And that gives you 151,200. 151,200. Okay. Now for part B, how many different color arrangements are there of the 10 books in which 3 blue books are together? So again, box method. But the 2 yellow books are not next to each other. So you can go about this in 2 ways. First of all, just um, box the 3 blue books together, right? Because first of all, you're talking about color arrangements, so they would be identical, obviously. Now, you can either make use of the gap method once again, right? Or you can use the fact that find the total cases and subtract that, no, subtract the cases where the 2 yellow books are together, basically. So the total cases would basically be you have this and then 3 Bs and then you have 7 left, 4, 5, 6, 7. So 7 factorial over 2 factorial 2 factorial. That would be your total case number of cases. Wait, hold on, my bad. Just keep in mind that don't forget to treat the block as one item as well. So you have actually 7 letters and one item or one block. So it would be 8 factorial ways to arrange them if there wasn't any repetition. But there is repetition in the red books and the yellow books. So that would be 8 factorial over 2 factorial 2 factorial. Those are the total number of cases. I'm not using the gap method for this, although you can use that. I'm just kind of going through all the methods that you can possibly use. Because usually for these questions, you can use multiple methods. Right. Now, these are the total methods. Um, there's no specific method which is better, although I would say that in this case, I do 6 factorial over 2 factorial into 2 factorial upon 2 factorial into 7c2. Put some time. Um, wait, hold on. Can you just sort of try describing your method? Because I am not, like, I don't really use that method, to be honest. You can either use this method of finding the cases or the total cases and then the cases when the 2 yellow books are together, right? So again, you have 5 remaining letters. So 1, 2, 3, 4, 5, and then you have to arrange 5 letters in 2 blocks. So basically that would be 7 factorial over, and then there's repetition for the red books. So over 2 factorial, right? And then you just do the total number of cases minus the cases when when the 2 yellow blocks are together. So 1, 0, 0, 8, 0 minus 7 factorial over 2 factorial. That would be equal to, let me just do this, minus 7 factorial um, over 2. That would give you 7, 5, 6, 0. I can um, for this, I guess you can use gap method as well. But anyway, um, okay, I'll move on then. Alright. Now, wait, neglect the two yellow that make factorial over neglect the two yellow. So you're basically hold on, you're ignoring the two yellow ones completely from your calculations. Choose two of the eight positions that are between. Choose two of the eight positions. Okay, so that's wait. Won't that basically be that feels like gap method? I don't know. Why does that feel like gap method to me? I might be wrong. You're choosing the eight positions that are between the numbers. Wait. Can you sort of send me a diagram or something if possible? I think that will help me visualize. Because usually for these ones, either I just box it, then you do total minus the cases which are not favorable, or I guess you can use gap method. Okay, I'll just move on till then. Right? You can send me your working. I'll take a look at that. Okay. So now these are some common type of questions which are annoying, but then if you understand how they work, they'll be free marks for you. Alright. So 5 of the 11 letters in the word requirement are selected. Now how many possible selections contain at least two E's and at least one R? So just keep in mind that in questions where they're asking you about selections, right? No matter what, whenever they're asking you about selections, um, and then when specifically it's not about probability, and I'll tell you the reason why when I come to this question. But when they're not asking you about probability, and when it's only just the number of ways or selections, always treat the identical letters as identical. Like don't think of them as E1, E2, E3. Just keep that in mind, okay? Because yeah, because the thing is for okay, I'll explain once I come to this probability question. So just keep in mind that for this you would consider the e's to be identical. So how many possible selections contain at least two e's and at least one r? So just identify all the number of e's and r's first. So one, two, three. You have three e's and then you have two r's, right? Contain at least two e's and then at least one r. So at minimum there have to be two e's and one r. So again, you can use multiple methods for this. Um, so I think most people would go about it by making two blanks and then thinking of the cases. So okay, like the first case when you don't have E and R, then the second case would be um, when you have like an E and R as well. So basically, sort of splitting up all the cases, right? So although there is a much better way, I'll talk about that as well. And then thinking about EER and then E for example, and when there is no other E and R, then again E, E, I, R, right? One, two, three, four. Apart from that, wait, what else can you have? E, E, R, E. Um, E, 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 R, E, E, R, E, E, R, E, R. Um, okay, I think yeah, that's the total number of cases you can have. Yeah, yeah, that's pretty much it. So then again, so for this case, then just think about the remaining letters you have apart from E and R. So in total, these are five, and then you're just left with six letters to choose from, right? So this would just be 6C2. This is basically just one case. This is 6C2. um, this is just 61 because for all the remaining blanks, you're basically considering the letters apart from E's and R's. And then again, this would be 61 as well. Now, however, there's a better method that you can use and still get 4 marks, right? So think about the minimum requirement. There isn't any sort of a upper bound or some upper, not an upper requirement, but just think about it as they're just telling you that at least there have to be these many letters, right? So E, E, and R, and you're left with how many? Two blanks. Now it doesn't matter if you have E or R or any other letter, basically. They would all count as cases. So what you can do is just simply think about the remaining letters apart from these three letters. So just apart from these, basically. So 11 minus 3, that's just 8. You're left with 8 letters, and you just have to choose any two letters. It doesn't matter which um, two letters you choose, basically, because they are all valid cases. So 8C2 would literally score you 4 marks for this. Instead of writing 4 cases and maybe missing out on one, you could literally just do 8C2 and get 4 marks, which is hilarious or crazy. Anyway, moving on. Find the total number of different selections of 6 letters uh, from the 11 letters of the word caterpillar that contain both R's, at least one A, at least one L. So for this, again, you can just first of all just start by listing the number of R's and A's and everything, right? So 1 and 2, you have 2 R's, unless I'm going blind. Um, Look, basically, for the HC2, right? They in the question they only gave you a minimum requirement. They just told you that hey, you need at least 2 E's and at least 1 R. There isn't some requirement that there has to be at most these many number of letters for E, for example, right? So no matter what two letters you choose from the remaining 8 letters, it doesn't matter. HC2 would consider all of your acceptable cases. So if you were to find out the value for HC2 or the value for like the first case, they would basically be the same. Exactly. Doesn't matter which two letters you're choosing from the remaining. Order does not matter here because they're asking you the possible selections. When you see selections, that means order does not matter. Do we count the E? Yeah, that's what I specified about. When you have these type of questions where they're asking you for selections, and when it's not probability, in that case, counting them as E1, E2, E3 would be absolutely incorrect. So when it's not probability and it is combination, do not do this thing. But um, which I'll explain why. But then for probability, you have to consider them as individual letters. Yeah, basically. And yeah. Anyway, moving on. So then you have how many A's? You have 2 A's, right? And you have L. How many L's? 2 L's. So again, start by listing out all these sections. So contain both R's, right? Both R's, at least one A. So at least one A and at least one L. And you have to choose how many? In total 6. So you, if I'm being honest, again, just think about it. Uh, there's just a minimum requirement, right? There's no sort of a maximum requirement. So I would just use the same concept as I did in this case. But then I'll just write the cases for the other method as well, just so that you guys get how it works. Okay, so you have RRAL dash dash, right? This would be your second method where you choose another L, right? There is not enough space. RRAL write the next one over here. So you can have RRAALL. Um, what else apart from this? You can, yeah, I think, yeah, that's pretty much it. So these are all your four favorable cases, right? This one would just be equal to one. You can only have one selection for this type. For, wait, too messy. Okay, now for RRAL, again, you have um, all these letters that you're avoiding. So six in total, right? So you're left with five, which from which you will actually choose the remaining letters. So that would be just 5C2. Then the same concept applies in the other cases as well. So here it would be 5C1. Hi, miss. What's up? Then this would be 5C1 as well. So this is your messy way of listing all the cases. Or we can use the same concept like we did in the past, like the previous question. So they were telling you that contain both R's, right? At least one A and at least one L. So you're just left with two gaps. And apart from these four letters, so basically 11 minus 4, which is 7, right? You're left with 7 letters. It doesn't matter which two letters you choose from those 7 letters. So you can just do 7C2. 7C2 would be your um, answer for this. So yeah, I mean these questions are confusing, but then not really confusing, but then you just have to list the cases and then you'll be fine. Right. Now we come to probability. Um, Before we dive into the question, I'll actually um, talk about why you have to consider the letters to be separate. Okay. So a bit of theory. Um, yeah. I hope it's better now. Okay. Bye. Right. I'll just talk about. Yeah, it's really close, but it's really close. Anyway, I'll just move on now. So, four letters are selected at random from the eight letters of the word this. You have to find the probability that the selection contains at least one O and at least one R. So, look, whenever you're dealing with probability, right? So, you usually define it as all the favorable outcomes divided by the total number of outcomes, right? So, favorable outcomes divided by um, total outcomes. Now, another thing is that um, in probability, and you can kind of realize, you can kind of see that you're dealing with probability and selection. So you can actually define probability in terms of combination as well. So it's basically favorable combinations divided by um, total combinations. You can also think of probability as that. Oops. Because it's basically doing the same thing. But now here's the issue. When you're using combinations, right? Like when you're doing total combinations, this thing over here is basically your sample space, right? Um, or like all the possible combinations that you can have. Now, if you were to think about all the total combinations for this part, um, four letters are selected at random from eight. So you're just doing 8C4 for your total combination, right? That would be your sample space. But here's the thing, when you do 8C4, right, you're actually considering all of the letters to, or like all of the items to be um, different or unique. You're not accounting for the fact that there's repetition or anything. That's just the way you define your sample space. It's HC4. You're choosing any random four letters from um, eight letters, and it does not matter if they're identical. So that's why, because in your sample space, you kind of define those letters to be separate, right? Like if you have, how many O's do you have? You have three O's. So three O's, and then you have two R's, right? So instead of being O and then R, it would instead be O1, O2, O3, and then R1, and then R2. And all of this depends on the fact that depends on how you define your sample space essentially. So that's why for probability questions, when you have to make use of selections, you think of them as separate letters. Okay, now we can actually dive into the question, and we don't have enough space, but I think it'll be fine. Okay, right. So find the probability that the selection contains at least one O. So let me just erase this. At least one O, and then at least one R. Right. So now you just think about all your favorable combinations. Um, you're choosing basically four in total. So that's your first case, obviously. Then you can have O R dash. You have, wait, let me just write it over here. You have three O's and two R's. So you could also have O, right? Um, Apart from that, wait, what else can you have? You can have O dash, and what else? Wait, hold on. O. Yeah, that is. Wait. Um, Hold on. Let me just see. OR. Then you can have ORR. Then you can have OOR. Right. Um, and then you can also have um OOR. Like you can also have three O's in one R. That just satisfies the question. Sorry, that just satisfies the condition. Now, remember the fact that you treat them as separate letters, right? So, I'll just do the working here. Okay, perfect. Now you have three O's. So, out of three O's, you're selecting one, 3C1 into 2C1, and then again, now in this, you would think about the remaining letters apart from O and R. So O and R add up to five letters. No. Now in this, you cannot use 6C2. That is a good question actually. Wait, let me try explaining why that happens. Um, if you have OR dash dash, right? This basically satisfies your question. Sorry, your condition. Um, but here's the thing. Wait, I had really good explanation for this. Just give me a minute to think about why you cannot use 62. Okay, so look, first of all, you have to consider them to be separate letters, obviously. That's for certain, right? So if you were to think about just this two, these two parts, you'd start by doing 3C1 and then 2C1. Now let's say for one of your examples, okay, let's say the O that you choose is O1, and then over here the R that you choose is R1, and let's say we use a logic of doing 6C2. So in this case, I'm doing into 6C2, right? So let's say I'm choosing O2 and then some random letter which I don't care about, T. Now, in some other case, okay, if we were to use this logic, if we were to use 3C1, right? Let's say O2, let's say you choose O2 over here, you choose R1 over here, and then, wait, no, not R1. I need a better example. So you choose R2 over here, okay. O2 over here, you choose R2 over here, and then using your logic of 6C2, you choose O1 and R1. What is the difference between these two cases? Keeping in mind that arrangement does not matter. They're basically the same cases, right? So you're sort of overcounting. Now we don't want to overcount because technically these two cases are the same. It's just selections. But what's happening is that in your first case you're choosing O and R first using your 3C1 and 2C1, and then after doing 6C2 you're choosing O2 and R2, right? And in the second case you're choosing O2 and R2 using 3C1 and 2C1, and then you're choosing O1 and R1. So order is different, but then again the selection is basically the same. So they would count as the same cases. So this would actually lead to overcounting, which you don't want to happen. Which is why for probability you cannot use that trick as well, unfortunately. Okay, moving on. So how many O's and R's do you have? Five, right? You're left with three letters to choose from. So 3C2. 3C2. Then for this, you do 3C1 into 2C1. Sorry, 2C2 into 3C1. Over here, you would do 3C2 into 2C2. And then over here, you do 3C2 into 2C1 into 3C1. And then here it would just be 3C3 into 2C1, right? So now you just add up all of the cases to get your final answer. Let me just plug that into my calci. Plus 2 plus this is 2C1. Uh, this gives you 50. Why did you do 3C2 um, 3C2 into 2C2? Are you talking about over here? That's because for probability, you would treat all the letters as separate. Like you won't treat them as identical letters. Are there any rules for finding probability in permutations? Um, I That's a good question. I don't think there have been any questions lately related to that. But then again, it's just common sense if you think about it. Just think about what your sample space would be, right? How you define your sample space. And depending on that, you have to think about how your favorable outcomes would be. Yeah, I think that's, yeah. So I'll move on. Sample space is basically weight. So you can think of it as the total outcomes that you can have. So thing, the best example would be, let's say you're rolling a die, right? You have a die. Now, if you're rolling a die, what you can get an outcome of one, two, sorry, how is it two twos? Three, four, five, six. So this thing over here is your sample space. These are the only possible outcomes. You can't have a 7 or a 0 or a -1. So that's your sample space essentially. Um, I would recommend you guys to practice these type of questions like where you have probability and selection. But if you use this concept of keeping in mind how sample space works, how that would affect your favorable outcomes, um, that then I think you guys can easily ace these type of questions, and the recording for this will be available as well. So if you guys aren't sure about anything, just go through the recording. Okay, so that's PNC. I think I have covered all the main methods that you can have. So I'll just go through some other topics as well, real quick. Some good questions, or questions that I found good at least. So over here you have a factory produces chocolates. 30% of the chocolates are wrapped in gold foil. So probability of GF, how ironic. Anyway, is 0.3. Probability of 20 wrapped in red foil, right? So wrapped in red foil is 0.25, and the remainder are unwrapped. So the probability of unwrapped is just 1 minus the probability of the first two ones. 1 minus 0.3 minus 0.25, which is just 0.45. So just start by listing this. Okay. Now you told that the person chooses chocolates one at a time at random from the production. The previous method had 5C1. Previous method had um, which question are you talking about? Has 5C1 into 2 into 5C1, and the second method has 7C2. Over here, I'll just clear it out right now. The second method has 7C2. Don't wait. Did you add up all these four cases? Let me just calculate that. 5C2 plus 5C1 plus 5C1 plus 1. 21. This is 21 as well. No, they would add up to. Did you add 1? The fourth case is when you have RRALL. Sorry, A double R double A double L. That is one case as well. So make sure to add 1 to that. I think that's where. Yeah. Okay, moving on. So find the probability that the second chocolate chosen is the first one wrapped in gold foil, given that the fifth chocolate chosen is the first wrapped in is the first unwrapped chocolate. Okay, so try writing that in terms of given, because you have the letter keyword given, right? So it's conditional probability. So first of all, the second chocolate chosen. So I'll just write it in words so that it makes more sense. Second chosen, no, chosen is too much. Is the first one is first one wrapped GF. Okay, given that the fifth chocolate chosen, so fifth chocolate chosen is first unwrapped. Okay. Oh, we don't have no space. No worries. Anyway, this would just be probability that, so intersection of um, these two events first of all divided by the probability that fifth is the first unwrapped basically. I'm just writing it so that it's easier to understand as well. So second chosen is first wrapped intersection this thing over here, too lazy, divided by probability that fifth is first unwrapped. This is how you calculate your conditional probability, right? Let me just see if my recording is going on. Okay, moving on. So first of all, start with the numerator part. you're looking at the probability that the second chosen is the first in unwrapped, and that the fifth chosen is the first unwrapped. Sorry, yeah, first unwrapped. So if you look at the numerator, it's first intersection second. For yeah, basically for conditional probability, if you guys want to revise it, probability of A given that B is just probability of A intersection B over probability of B, and also if they are independent events, since probability of A intersection B is equal to probability of A times probability of B for intersection events, that would basically kind of cancel out to give you probability of A. But this part is only for independent. Yeah, you can just remember that and then do it. Independent events. Okay, I'll just erase this bit actually. I'll just write it over here. Psi. Okay, moving on. So for the numerator part, the second chosen is the first wrapped, and the fifth chosen is the first unwrapped, right? So if you think about it, um, I mean, you you don't necessarily have to use geometric actually. Just think about it. The second chosen is the first wrapped, right? So um, second chosen is first wrapped, first of all, and the fifth chosen is first unwrapped. So what about the first chocolate that you choose? That actually won't be unwrapped or wrapped. So you can think about it as um, yeah, my bad. I should specify that. Wrapped in gold foil. Yeah, thank you. Anyway, so for the first chocolate, if you think about it, since the second chocolate would be the first chocolate that's wrapped in gold foil, and the fifth one is the first one that's unwrapped, so it would be 1 minus 0.45 minus 0.3. Yeah, so basically the first chocolate would be the one which is wrapped in red foil. So that's just 0.25, right? Because again, I'm pretty sure it makes sense. High strawberry. So 0.25 times. Now for the second one, they tell you that it's the first one which is wrapped in gold foil, which is important, as Miss said. Um, then here's the thing: the third and the fourth chocolate will be the ones which are basically not unwrapped, right? Because the fifth one is the unwrapped one. So you can just do 1 minus unwrapped, and that would give you 0.55. So the logic is that it can either be wrapped in gold foil or it could be wrapped in red foil for the third and the fourth one. So that's just 0.55 squared. 55 squared times the fifth one is the first one unwrapped. So 0.45. This is too messy. I will erase this. Okay. So you get for the numerator bit 0.25 into 0.3 into 0.55 squared into 0.45. Now divide that by your probability of, wait, what was it? The probability that the fifth chocolate chosen is the first unwrapped. So for that, the first four ones would be wrapped basically, right? So that would just be 0.55. So 0.55. So yeah, so if the second chocolate is the first one to be wrapped with gold foil, then we can be sure that the first chocolate is wrapped with red foil. Exactly, because The first unwrapped is the fifth one, and the first wrapped in gold foil is the second one. So that just leaves you with the one which is wrapped in red foil. And then the third and the fourth blanks can be anything. It can be wrapped in anything. Okay, that raised to 4 times the fifth one is the first unwrapped, so 0.45. And this would give you your final answer. Let me drink water as well. I need to hydrate. Don't forget to hydrate. Okay, I'm back. You have only 15 people, man. Anyway, okay, let me just cancel out this and calculate the answer. So 0.25 times 0.3 times 0.55 squared divided by 0.55 raised to 4. That gives you 30 over 8. 30 over 121, which is your final answer. By the way, why 0.5 raised to 2? Okay, so uh, I'm pretty sure you understood as well that it's basically red, gold, dash, dash, and then unwrapped, right? So for the dash part, it can either be wrapped in red foil or um, wrapped in gold foil, right? So you just add up the probabilities of it being wrapped in gold foil or red foil. 0.3 plus 0.25. So 0.55 into 0.5. Exactly. You can have multiple cases. So yeah, that's how you would get 5 marks. Any other doubts? Um, the thing is, it's mainly RG, ROG, exactly. Yeah, there you go. It can be R or G. Honestly, if you want to think about all the cases, um, you can do that, but then just keep in, just using the uh, rule that if it's this or that, you just add the probabilities. Anyway, no. Moving on. Okay. So to this part, um, so Jay and his wife Kaz are having a party. He has 5 friends. Each friend will bring his wife. For competition during the party, 12 people are divided into a random group of 5, a group of 4, and a group of 3. Okay. Now find the probability that Jay and Kaz are in the same group as each other. So for this, the thing is that they could either be in the group of 5, right? Or they could be in the group of 4, or they can be in the group of 3. So you'd actually have 3 alternative or 3 multiple cases for this. Those would be all of your favorable outcomes, right? So again, just start by making dashes for this, to be honest. Um, any doubts so far? Thank you, Strawberry. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. Again, 1, 2, 3, 4, 5. 1, 2, 3, 4. And 1, 2, 3. So either they can be in the group of 5. Again, order does the arrangement does not matter in this case. Um, then they could be over here. Okay, yes, I believe I posted the drive a while back, but let me just post it again. Um, I'll upload the solved one as well, so you guys can refer to it. Um, okay, moving on. So you can have J and K in the second group, or they can be in the third group. Now you just think about, for your favorable outcomes, just think about how you'd arrange the remaining people, right? So you have 12 people in total. So remaining are obviously, wait, let me just write it because you guys will refer to this as well. So 10. Now just think about how you arrange, not arrange them, how you choose them in the remaining, or select them in the remaining gaps. So this would be 10C3 times, you're left with 7, so 7C4 times 3C3, which is this one, but I'll just write it. Then you have 10 again, so 10C5 times, you have 5, so 5C2 times 3C3. Then again you have 10C5 for this as well, times 5C4 times 1C1. Now these are all of your favorable outcomes. Keep that in mind because this is the probability, right? So you just add all of these up. So 10C3 times 7C4. 3C3 is just 1, so you can ignore that. Plus 10C5 times 5C2. Okay. Then plus 10C5 times 5C4. 5C4 is just 5. You can kind of remember those tricks as well. So if you have NCI, that is the same as NCN minus R. Or you can think about it as the Pascal triangle if you're doing P1. So there is a sort of a symmetry, which is why you can use this rule. But anyway, um, right. So 10C5 times 5C4. Okay. And then that would add up to give you 7980 as your favorable outcomes. Now you have to think about all the total outcomes. So in total you have 12 people. So for the total, this is for favorable. For total you just do pretty easy. 12C5 times, wait, hold on. 7, oh my god. Okay, my laptop's tweaking. 7C4 times 3C3. And then you just find the probability. So this is equal to 12C5 times 7C4. 27720. So F over T, basically favorable over total, which is 7980 over 27720, which would be 19 over 66. And that is your final answer. That's 5 marks. Okay. Now we come to some questions where you have to make a sample space. Um, 8. Um, yeah, okay. So moving on. So Jasmine throws two ordinary fate six-sided dice at the same time and notes the numbers. Okay, so you have two events, A and B. Now for event A, you have to find the condition is that the sum of the two numbers is less than 6. For event B, it's that the difference between the two numbers is at most 2. Determine whether or not the events A and B are independent. So the condition is that if P of A times times P of B is P of A intersection B, then it is independent. Okay. Oh, wait, I don't have enough space. It's fine. Okay. Anyway, so usually for these questions, you start by sort of listing out all the possible cases using these two dice basically. So event A, if you think about it. So for making the sample space, here's what I usually do. So just write the numbers it nice. 1, 2, 3, 4, 5, 6. No, that's too messy. Wait. 1, 2, 3, 4, 5, 6. Um, yes. Which is essentially your sample space, right? Yep. I am speaking source here. Okay. Anyway, right. So for event A, right, it's just sum of the two numbers. So just add up all the numbers and write the sum. One, sorry, two, three, four, 5, 6, 7. Um, 3, 4, 5, 6, 7, 8. I'll just write everything down. 5, 6, 7, 8, 9, 10. This 5, so 6, 7. Right. Okay. Now this is for all these sums. Now event A is that the sum of the two numbers is less than 6, right? So first of all, check where 6 is basically. 6 is right over here. These are all the sums that you get for 6. No, I think I wrote something wrong. 3 plus 1, 4. Wow. Anyway, all of these sums above this, if you think about it, would be less than 6, right? Now moving on to B. So the same thing, but in this case, you're talking about the difference. And when they say difference, you take the positive difference. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 0, 1, 2, 8. No, hold up. 1, 2. No, no, yeah. Why am I tweaking again? Three, 4, 1, 0, 1, 2, 3. Yeah, it's fine. I think most of them are probably going to just watch the recording. I don't really mind as long as I'm helping out. So 6 minus 4, 2, 4, 3, 2. You have 1, 0, 1. 5, 4, 3, 2, 1, 0. Okay, yeah. Um, so this is B, right? Now, for event B, it's that the difference between the two numbers is at most 2. So, at most 2 means it has to be less than equal to 2. So, if you just think about it, it would be from here till right about here. Anything greater or below those lines would not be considered, basically. Anyway, now just list what P of A is, right? So the total outcomes is just 6 into 6, which is 36. The favorable ones would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 over 36. P, hold on, P of B would be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. 22, 23, 24. This is 24 over 36. Now you have to look at the intersection between A and B as well. So how I would do that is just think about the overlap between this line which I drew for the A table and then for the B table. So this line would be starting from 5 1 right over here, right? 1 2 3 4 5 5 1. Then it would move on to 4 2. If you think about it, then it would move on to, no, sorry, wait, just let me see, 5 1. Okay. um no, sorry, it's 4 1, that's why I was doing it wrong. 4 1, and then you have 3 2. Okay, you have 2 3 after that. um After 2 3 you have 1 5. So kind of like this. It's really messy, but I think you guys got it as well. So for P of A intersection B, this overlap between the two regions is in a way the intersection. So let me just list that. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Wait. Um, think I might have done something wrong. Um, this is for B. The difference between the two numbers is at most 2. The sum of the two numbers is less than 6, right? Sum of the two numbers. Wait, what did I do wrong? Oh wait, okay. No, this would be the shaded region. My bad. I took the wrong part. You take the intersection between those two regions, which would be this part, not the other part. Okay. So P of A intersection B is 1, 2, 3, 4, 5, 6, 7, 8. Yes. 8 over 36. And then you just have to prove that A over 30, sorry, 10 over 36 times 24 over 36. And if you just calculate the value, so 10 over 36 times 24 over 36, that's 5 over 27. Uh, this 5 over 27, that will not be equal to 24 over 36. So that's why it's not independent. Um, for this, I just wait. Yeah, I wrote 8 over 36 here, right? So you got 24 over 36 with the original statement, and so 24 over 36 is for B, right? Now think about it as this new thing over here is kind of like A intersection B. I'm kind of overlapping those two regions to find the intersection, basically. This isn't B, this is like A intersection B. Now, because I made those three boundaries. So you kind of, for A intersection B, you're considering this condition as well, along with this, basically. That's how you'd get 8 over 36. At least that's what my method is. If you guys have any other method, that's fine as well. Okay. Wait, not enough space again. Um, okay. find P of B given that A complement occurs shouldn't be equal to 527 is A intersection B, right? We got that P of B is, yeah, that's what I wrote, right? I P of A times P of B is P of A intersection is not equal to P of A intersection B. 10 times 36 times 10 upon 36 times 24 over 36 is 5 over 27, which is not equal to 8 over 36. That's what I wrote. Yeah, maybe I'm just a bit tired, but then it's fine. Um, wait, this part is clear, right? There's okay. We'll move on. Now for this, it's just P of P intersection A complement upon P of A complement, right? So P of P intersection A complement. So if you think about it, for P of A, right, it was the sum of the two numbers is less than 6. So A complement is the fact that the sum of the two numbers is more than 6. So in a way, it's the shaded region. Not the shaded region, but the region which is greater in a way. So we can again use that thing of comparing regions, if you guys understood that. So A complement would be all the region below, and then that intersection B. And P of B was that the difference between two numbers is at most 2. So you can kind of refer to this one over here. Okay. For that, we had found out these sort of two boundaries for P of P, right? These two parallel lines. So you can use that to your help once again, to your aid. So kind of like this. So then you had some things going from here to 4, and then 3 3 8 no 5 4 actually. I'm not sure if you guys, yeah, that would just be the complement of, that would just be 26 over 36. You don't have to do that much work for A complement. It's just this bit. It's a 5, and then hold on, just give me a minute. 5 3, you have your 8 4 and 6. I don't like this. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, and then 16. 16 over 36 divided by 26 over 36. Okay, the glow effect. Anyway, moving on. So just cancel out the 36. That's just 60. 16 over 26, which is 8 over 13. So that is your final answer. I'll try not to complicate it too much. I feel like I am doing that. Anyway, moving on. This is a really easy question, but then I don't know. I just wanted to include it because some people might mess up in it. So you're given three probabilities for some sort of a service. So probability that it's good or satisfactory or poor. And then three residents of Maheng. Wait, no, I don't know how to pronounce that. So finally, probability that one resident classified the bus service as good. So that's just 0.25. One as satisfactory. So one as, so good and satisfactory and poor. So times 0.6 um, times 0.15. But now here's the catch. Uh, this isn't the total probability because keeping in mind that all the three residents are different, right? If you think about it, this is the first resident, this is the second, and then this is the third. They could either classify it as 0.25, 0.6, 0.15, or it could be 0.25, 0.15, 0.6. That would be something different as well. So you have to consider all the cases where the residents classified differently. Then moving on, zero point 0.6, so you have 0.25, 0.15, um, what else? 0.6, 0.15, 0.25, okay. And then last is 0.15, so 0.6, 0.25, 0.15, 0.25, 0.6. So if you just add all of this up, 1, 2, 3, 4, 5, you have 6 cases with the same probabilities. So 6 times this would be the probability that they classify it in such a way. Or you can also think of it as 3 factorial, although I think listing all the different cases in which the residents can classify the bus service would be better. I mean, yeah, in a way, it's just you're just rearranging, right? I mean, that doesn't make sense at all. But then think about all the different ways in which the residents can kind of um, classify it, right? Like if you can see, these are all your cases. So that's why I feel if you did 3 factorial, that would be right as well. Although I just think that's a bit risky. So anyway, moving on to discrete random variables. So you have Sanket who plays a game using a biased die, which is twice as likely to land on an even number as on an odd number. Okay, so multiplying cases with the number of cases. Um, exactly, because in this there's only one way in which the cases can occur, but then you just have to think about the total number of cases. So just keep that in mind. Anyway, in this you're told that um, the probability of landing on an even number is twice as likely to land on an odd number. Let's say that probability of odd is x. So probability of even would just be twice as likely, which is 2x. And in a die, you just have 3 odds and 3 evens, right? So find the probability of throwing an odd number um, with this die. So basically the value of x in this case. It's for 2 marks. So you can use the rule that um, all the probabilities must add up to 1. Summation of p brackets x is equal to x is 1. So 3x, because you have 3 odd numbers and they have the same probabilities, right? Um, they've told you that even the probability for all the 3 even numbers and odd numbers is the same. There's only one case, just, yeah, essentially. And then the probabilities for the odd numbers are also equal. So 3x plus 3 times 2x, which is 6x, is 1. X would be equal to 1 over 9, which is your final answer. Moving on. After that, you have Sanket throws the die once and calculates his score by the following method. If the number thrown is 3 or less, he multiplies the number thrown by 3 and adds 1. Okay. And if the number thrown is um, more than 3, then he multiplies the number thrown by 2 and adds 4. And the random variable x is Sanket's score. So he basically throws the die, he gets some sort of a number, and he does this calculation based on the value of the number to get the score x. Pretty straightforward. Now, show that probability of x is equal to 8 is 2 over 9. So the probability that Sanket's score is 8 is 2 over 9. Okay, so now you have to think about um, basically how you can attain the score 8. So if you look at the first case, right, if the number thrown is 3 or less, so 1, 2, 3. If you think about it, if you get a 1 multiplied by 3, that won't be big enough. If you multiply 2 by 3, so 6 plus 1, that would be 7. So that's not good enough either. 3 times 3, 9 plus 1. So this, you basically don't consider this condition. Now, if the number thrown is more than 3, he multiplies the number thrown by 2 and then subtracts 4. So since he's subtracting 4, let's say you did the opposite. If you added 4 to 8, so that would be 12, right? And then he multiplies the number thrown by 2. So 12 is equal to 2y, for example. So basically when the number thrown is 6, right, that's when he gets an 8. So probability of throwing 6, and keeping in mind that the probability of throwing an even number would be 2x, right? That would give you 2 over 9. So yeah, that's pretty much it for this bit. And then moving on. So given that e of x is this, and then you have to find the variance. So pretty easy. Variance of x is just e of x squared minus e of x the whole square. I won't show the calculations for finding e of x squared, although you do have to show the calculation for that since there's not a lot of space. So I'll just do it in my calc. 4 squared times 3 over 9 plus 6 squared times 1 over 9 plus 7 squared times 2 over 9 plus 8 squared times 2 over 9 plus 10 squared times 1 over 9. So 410 over 9, 0, 3, that minus 58 over 9 the whole square. That gives you 326 over 81. So again, these type of questions are pretty easy. Now find the probability that the total of the scores on the two throws is 16. Now keep in mind that um, first of all you're finding out when the total of the scores is 16, right? Um, I think I skipped a part of this question, but this is basically a new part. Okay. Um, yeah, I fear I missed that. Anyway, the you basically have two dice, okay, and you're throwing them, and the scores would basically add up. The values of them of those dice would basically add up. So think about how you can get 16 based on these. Wait, no, it's not a die actually. Um. Oh, yeah, my bad. It's. I'm not really. Wait, hold on. Give me a minute. Those are Taiwan's calculates a score by the following method. Okay, shows the probability distribution of x. So basically, a probability distribution of the scores, like all the ways in which you can get some sort of a score. It's just a table for that. And then uh, he is throwing the die twice, okay? And those two scores are basically adding up. Okay, there we go. So the first way that can happen is obviously if you get 6 comma 10, but then again you could get 10 comma 6 as well, right? And then you could also get 8 comma 8. That could be your third case. In all of these cases, the scores from the two throws would add up to 16. Um, and yeah, there is not anything else. So just find the probabilities of these three throws and then add them up. Okay, so the probability for getting a score of 8 is 2 over 9. And since you're throwing it twice, it will be 2 over 9 squared. That plus, so 6 comma 10 and 10 comma 6 would be the same probabilities. Um, Not for too long because there's just 2 pages left, right? So I'll just cover a bit of distributions and we will then wrap up. So yeah, we are almost done. So moving on. So the probabilities for these two um, cases would be the same. So you can just do 2 times probability that you get 6. Hold on, let me see. Yeah, we started from 10. I skipped the histogram and then all of that because I believe that's doable. So, oh, anyway, right. So you have 10 and 6. So probability of getting a 10 would be 1 over 9 times probability of getting 6 is 1 over 9. So just add up all of this. Okay, so adding all of that gives you 2 over 27. Yeah. Given that the total of the scores on the two throws is 16, find the probability that the score on the first throw is much more important. Yeah. Anyway, moving on. So find the probability that the score on the first throw was 6. Probability that first throw was 6, given that the score, total score from the two throws is 16. So intersection of this and this is just 6 comma 10. So I'll just set it as probability of 6 comma 10 over probability of basically getting 16, which we calculated already, right? So that would just be um, 1 over 9 times 1 over 9, which we already know. That divided by the probability we calculated before, 2 over 21. That is really that the score on the first one was 6. Hold on, let me just see whether I did everything right. Um, 1 over 81 the whole divided by probability that the score is 16. That's 1 over 6. Okay. And yeah, now we just have distribution. It's just 2 pages, so it won't take that long, hopefully. Although this is a really good question. Okay, so Rachel and Sophia are competing in a javelin throw competition. The distances r meters thrown by Rachel can be modeled by a normal distribution. Okay, so r can be modeled by a normal distribution with the mean 56.5, comma standard deviation as 3. Sorry, variance as 3 squared. I have to mention the variance. Then you have s. Okay, there's something similar, but it's 57.5, comma 1.8 squared. So these two distributions are basically the distances that Rachel and Sophia can throw, like how far their javelin can travel. Now, in the first round of competition, each competitor must have 5 throws. To qualify for the next round of competition, a competitor must record at least one throw. So, out of 5 throws, you need to have at least one throw, right? So, must record at least one throw. So, you're first somewhere you know that you're finding out probability of one is greater than equal to uh, probably that sorry x is greater than equal to 1 where the number of throws is 5, so total number is 5. Okay, we'll keep that in mind. Now a competitor must record at least one throw of 60 meters, right? Now for Rachel and Sophia, the probability that they record or they throw that far is going to be different. So for both of those people, you would have to find out probability x is greater than 60 for Sophia, probability that x is greater than 60 um, for Rachel. So that's what you have to find. And then they're saying find the probability that only one of Rachel or Sophia qualifies. So Rachel would qualify and Sophia would not qualify, or Rachel would not qualify and Sophia would qualify. Those are the two cases you're basically looking for, right? So moving on. First of all, just find out the probabilities for Sophia and Rachel, like uh, probability that they throw more far than 60 meters. So it's just a normal distribution, right? So probability of x less than 60. I'll just divide this. Is there enough space? There is. Yeah. Okay. Moving on. 1 minus probability z less than. So I'll just write the value 60 minus 56.5. That divided by 3 is 1.166. 1.166. And over here 1 minus probability of x less than 60 for Rachel. So that's 1 minus probability that z is less than. So 60 minus. Oh wait, hold on. I think I swapped them. Uh, yeah, I think I didn't. Wait, hold on. Yeah, so this. Okay, this will be for Rachel. This will be for Sophia. Anyway, moving on. 60 minus 57.5 upon 1.8, right? So that gives you um, 1.388, right? You just have to use your MF19, or you can actually even use your calculator to just find out the area. So, wait, 1.16666. So 0.8770 plus 0.0012. And you subtract that value from 1. So you're left with 0.1218. That's the probability for oh shoot, Rachel. Yes, that's the probability for Rachel that x is less than no x is greater than 60. Similarly for Sophia, we would do the same thing, 1.388, 1.388, and 162 plus 0.0013, right? Then you just do 1 minus that to get 0.0825. But that's not the end of it. So, hold on. Okay. To which places do you add the numbers? Um, wait, are you talking about over here? Just take 3 decimal places for the z value, right? Because that's the maximum you can take. So, like, this is the first decimal place, this is your second decimal place, and this is your third one. So, and make sure you round it off correctly as well. Just keep that in mind. Okay. So you have the probabilities that x is greater than 60. Now moving on. Now basically, you have 5 throws, right? And out of 5 throws, uh, um, a competitor must record at least one throw of 60 meters. So you kind of get the idea that the probability that there is some sort of a success or that they threw 60 meters, you already calculated that. So this is going to make use of a binomial distribution in this case, where n is 5 and you're finding out p is probability of x greater than equal to 1. And that's the same as the complement, which is x less than 1, right? So 1 minus probability x is greater than, sorry, x is equal to 0. So that's your binomial for both. So you have to actually find out the probability for both that rec- they basically record at least one throw of 60 meters. That's what you're basically trying to find out. So make a binomial distribution now with the success that they throw um, n comma p, right? 5 comma they throw 60 meters or more, and then 5 comma 0.0825, and then after that you just do 1 minus probability that x is greater than equal to 0. So I'll just use my calc at this point, right, to calculate the probability that basically Sophia or Rachel throw um, more than 60 meters in one in out of 5 throws at least once. You have basically find that out. So in fact, you can just use your calc to do that, but then make sure you show the working. So 1 minus IC0, which is 1, then q raised to 5, 1 minus 0.1216, 1 minus, wait, hold on, 1 minus 1 minus 0.1216, the whole raised to 5. That would give you 0.477 for Rachel, and for Sophia it would be 25 raised to 5, 0.349. Okay, so this is basically the probability that Sophia or Rachel qualify for the next round. Now you have to find the probability that only one of Rachel or Sophia qualify. So it's either one qualifies and one doesn't, and this is for qualifying, right? This is the probability that they do qualify. So you do 0.477 times 1 minus 0.349, because the other one does not qualify, that plus when Rachel doesn't qualify, so 1 minus 0.477 times 0.349, so 0.182527. Okay, no, that's really messy. Anyway, we're almost done anyway. So, okay, adding that, adding those two values up would give you 1. So once you add that up, that gives you 0.493. And that is your final answer for this 7 marks. Nice. Um, I feel this bit is pretty. The first two parts are pretty easy, so I'll just skip that. But then for the third one, uh, they're telling that in a random sample of 365 days, how many days would you expect the mass of um, grapes sold to be within 1.3 standard deviation of the mean? So first of all, um, wait, let me check the MS for this bit because, or it's actually easy to calculate. I'll just do that. Then. So find the standard deviation of the masses of grapes sold per day. So they're telling you that 10% of day less than uh, 6 kg of grapes are sold. Probability that x is less than 16 is 0 0.1. High. So yeah, just do that. And then 16 minus what's the mean? That's 28. You know the standard deviation. And this thing on the left side is just your z value. Now you just have to find out the z value for 0 0.1. And if you think about it, um, find out the z value for um, oh, you missed it. Anyway, find the z value for 0 0.9. Okay, because if you think about it, if you do 1 minus 0 0.1, that gives you 0 0.9. So the z value for 0 0.9 and 0 0.1 are just like they have the same value, but then they're like one of them is negative. The z value for 0 0.1 would be the negative of the z value for 0 0.9, if that makes sense. And you have this critical values for the normal distribution, so just use that. So for 0 0.9 it's 1.282, right? So for 0 0.1 it would be minus 1.282 minus 1.282, and then you get the standard deviation to be as that's 9.36. Okay, moving on. The masses of grapes sold on any day is independent of the masses sold on any other day. Okay. Now 12 days are chosen at random. So first of all, this over here gives you an idea of the fact that since um, these are independent events, right? Like on every single day, these events are independent. So this could potentially be a binomial distribution. Now, 12 days are chosen at random. So n is pretty small as well. So, okay. And then find the probability that less than 16 kg of grapes are sold on more than 2 of these 12 days. So this is going to be a binomial distribution where you have to find the probability that this is sold on more than 2 of these days. So x is greater than 2 basically, where n is 12 and your success is that less than 16 kg of grapes are sold. And they already told you that on 10% of the days less than 16 kg of grapes are sold. So your success in this case would be 0.1. So p of x greater than 2 is the same as 1 minus p of x less than equal to 2, which is 1 minus p of x being 0, 1, 2. Okay, now you just calculate that. So again, pretty easy. Um, so 0.9 raised to 12 plus 12 times 0.1 times 0.9 raised to 11 plus 12c2 times 0.1 squared times 0.9 raised to 10. 1 minus 0.8891, 8891, which is 0.11. 3SF, so 0.111. Now, in a random sample of 365 days, okay, keeping in mind that the original distribution is defined as the masses of grapes sold per day, okay, so it's kind of like a rate. Anyway, in a random sample of 365 days, how many days would you expect the mass of grapes sold to be between 1.3 standard deviation of the mean? So basically, the probability that z is greater than minus 1.3 and less than 1.3. Oh, who's the speaker now?
Apologies, just to say that I think the session starts in about 10 minutes, just to be very referring to that.
Well, yeah, we're just wrapping up anyway, so yeah. Okay, so moving on, this is the last part. So, right. So whenever you're dealing with normal distribution, right, you have something like this, and in this case, your normal distribution is defined as the mean with mean 28. Um, yeah, okay, perfect. And the standard deviation is 9.36, right? So the variance is 9.36 squared. Now this is a normal distribution in this case. However, for doing your calculation and everything, you have to standardize it. So whenever you do this thing of um, z is equal to x minus mu over standard deviation, this is basically a formula for standardizing uh, this distribution over here to x is a normal distribution of a standard normal distribution where the mean is 0, okay, and the standard deviation or the variance is 1. So whenever you're using this formula, in fact, you're just standardizing it to your standard distribution. Anyway, so if you think about it really, your standard deviation in this they're telling is from 1.3 to minus 1.3, right? So if you were to make it or just mark it, it would be like this. Sorry, I think I missed this, but can you explain part A where it's like 16 minus 28 over standard deviation? So basically, the rule is, wait, let me just show you. If you have a standard deviation, right? Let's say the area till this bit over here is uh-huh is 0.1, okay, and this is 0.9 over here. So the z values for 0.1 and 0.9 will be not the same, okay, so they'll be like one would be the negative of another. So in this case, the z value for 0.9 is 1.282, right? So because of symmetry, the z value for 0 0.1 would be minus 1.282. That's how it works because um, think about it in terms of area. The area for the area covered till 0 0.1 is basically 0 0.1, right? And it's in a way symmetrical. Like this area over here is also basically 0 0.1, but it's like on the opposite side of your mean. So technically the area to the right of 0 0.9 is 0 0.1, and that's the same as the area to the left of 0 0.1. So this area and this area over here is same, and it's like around the mean, which is the reason why the z values would be like this. So the z value for 0 0.1 is basically minus 1.282 because for the z value for 0 0.9 is 1.282. So it's just using symmetry. Moving on to the last part, right? So, so your standard deviation is basically the same as your z value for your standard um, distribution. Okay, so um, you just find out the area between the z value minus 1.3 and 1.3. So hold on. Probability of z less than 1.3 minus probability of z less than minus 1.3. And then you can basically use this rule over here that's mentioned in MF19 as well. So for a negative z value, it's the same as 1 minus phi of z. Okay, so probability z less than 1.3 is 1 minus 8. 1 minus probability that z is less than 1.3. We're almost done. So 2 probability of z. Oh, alright, perfect. Z less than 1.3 minus 1. Thank you. So now you just find out the area for that. 2 phi of 1.3 minus 1. So what's 1.3? It's going to be this, which is 0.9032. So 2 times 0.9032 minus 1. Okay, and then you just use your calci and then find the area between it, principally, which turns out to be 0.8064, right? 0.8064. Now just go through the question again. This is the probability that the mass of grapes sold is within 1.3 standard deviations of the mean. But your random sample is of 365 days. It's not for one day, right? This is the probability that the mass basically lies between a certain standard deviation, kind of like per day. Now you have to calculate the number of days that the number of days that this would actually hold true, right? So you'd multiply this by 365. So 365 times the probability of that occurring, 0.8064. And that would give, that would come out to be as 294.36. So you can round it down as 294. You can round it up as well, that works. And then yeah, that's pretty much it, guys. Thank you all for staying till the end. I will be adding the salt That's it from my side, though. Thank you so much. Everybody's gone.